Hey guys, welcome to the video for solving missing sides using trigonometry ratios. So in this video guys, we are going to be solving for missing sides of a right triangle using trigonometry. This is a core skill of coordinate plane geometry, and you're going to know you're successful when you can write and then solve a proportion for trigonometry. You should be following along on page 4 of your packets. Alright, so it's all about SOHCAHTOA, guys. So the SOHCAHTOA shortcut that I gave you guys in class is going to be the most important thing here. You're going to identify your reference angle. You're going to pick which trig ratio you need to use based on the sides that you are given and the one that is missing. And this is where SOHCAHTOA comes into play. If you are looking for the opposite side, you're going to need to use either sine or tangent, depending on which other side you're given. If you're looking for the hypotenuse, you're going to need to be able to use sine and cosine, depending if you're given the opposite or the adjacent side. And if you don't have any hypotenuse whatsoever, you're going to use tangent to calculate the measurement of that side. You're going to write a trig ratio using the reference angle measurement. And then using proportions, you're going to solve for the missing side measurement as well. So let's get to it. First thing you got to know is, what is a reference angle? A reference angle is an angle that we use to orient ourselves and label our opposite and adjacent sides. So in the sample that I have here, the sample triangle, theta is my reference angle. That's what we usually refer to our reference angle with. That's the symbol we use. The opposite side is labeled as such because it is literally opposite across the entire triangle. And the adjacent side is right next to it. So if I draw like a dashed arrow in here, that's to say that is the opposite side. And then this one here is adjacent. So hypotenuse, this one up here, the hypotenuse is always fixed. It's the longest side, and it's the one that is across from the 90-degree angle. So this angle is so important because it literally determines which of the 3 trig ratios we need to use. So, proportions. The other skill, the mathematical tool that we're going to be using to solve for missing sides is a proportion. We're going to cross multiply and solve a proportion. Cosine of 32 equals x over 12 is a set up trig ratio that I can then solve by cross multiplying. And what I can do is put something like cosine of 32, I can put that over 1, and I can cross multiply these things. So it would be 12 times the cosine of 32, and then that would be equal to x. So I can go ahead and multiply or divide those things correctly using the idea of cross multiplication, just like you would a fraction. Like if I did x over 2 equals 12 over 48, I could cross multiply and solve those things. So I would get 48x equals 24 by cross multiplication, and then I can solve. Dot, 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 I can solve. So example 1, we're going to write a trig ratio for this triangle, and we're going to see what happens when the variable is the one on top. So 25 degrees is my reference angle. So this right here, this is going to be my reference angle. I'm going to say RA for reference angle. And if I look at this triangle from the 25-degree reference angle, I have, this is the opposite side here, and 14 is the hypotenuse. So I've got x is opposite and 14 is the hypotenuse. So if I write out SOHCAHTOA, the ratio that involves O for opposite and H for hypotenuse is SO. So that means I can write the sine of my reference angle, the sine of 25, equals, and then I'm going to write my trig ratio on the other side. or I'm going to write the fraction on the other side. The opposite side, x, which is the top of my fraction, divided by the hypotenuse. So here's my written trig ratio right here. Okay, so this is my written trig ratio. Now I'm going to solve it. Okay, the sine of 25 is equal to x over 14. So what I'm going to do to solve it is write the sine of 25 over 1. And that is equal to, this fraction on the other side stays the same, x over 14. So now what I can do is I can treat this like any other proportion. I can just cross multiply these things. And I'm not actually doing any multiplication until I actually am ready to punch this into my calculator. I'm just going to write it out like I did the multiplication. So it's going to be sine of 25 times 14. So sine of 25 times 14 on the left side, and 1 times x on the right side. 1 times x is just x, so I am solving directly for x, which is nice. What I am going to need to do now is, in my calculator, I am going to need to punch in the sine of 25 and multiply it by 14. So the sine of 25 is about 0.4226, and I'm going to multiply that by 14. And when I do, I get 5.92. And with these side measurements, we're going to round them to the nearest tenth. So this is the number that I want you to round to. So it's going to be 5.9 is approximately equal to x. And that's it. That's what happens when the variable's on top. Pretty easy. Let's take a look at an example where the variable is on the bottom of my trig ratio. So what I'm going to do is identify which trig ratio I'm going to use again. From here, this is my reference angle. It's the measurement that I am given. 11 is opposite that. I have to go all the way across the triangle. 11 is opposite that. And x is the hypotenuse because it's across from the 90-degree angle. So what I'm going to do is set up my trig ratio. Again, I'm finding this is opposite and hypotenuse. So again, I'm using sine for SOHCAHTOA. So the sine of 64 is equal to 11 over x. So that's the trig. That's the actual trig ratio. Sine of 64 equals 11 over x. That's the fraction part, the ratio part over here. What I'm going to do is put sine of 64 over 1 right away. And then I'm going to go ahead and cross multiply. So when I cross multiply, I get x times the sine of 64 equals 11. Now, I want to solve for x, okay? And sine of 64 is just a number. I know that it's written out and it looks all weird, but right now it's actually just a number. So what I can do is I am allowed to divide both sides of the equation by the sine of 64. That is totally doable. You can totally do that because it's just a number. So I'm going to do that. It's going to cancel it on this side and leave me with just x. So what I need to do is the sine of 64 is 0.8988. So I'm going to take 11 and divide it by 0.8988. And when I do that, I get 12.24. And I want my side lengths to 1 decimal point. So 12.2 is the length of this side, or excuse me, of the hypotenuse here. And if you do a reality check, it makes a lot of sense too, because the hypotenuse should be larger than the opposite side, because the hypotenuse should be the largest side in your right triangle. Okay, so in your packet, you've got this triangle that says solve for side H in the right triangle below. What is the reference angle? The reference angle, the only angle we're given besides the 90 degrees, is 38 degrees. So that is your reference angle. Which trig ratio should we use? Again, we're going to use sine here because I've got an opposite h and hypotenuse 15. So from the reference angle, this is opposite, and 15 is the hypotenuse. So we're going to use the sine. So using that information, the sine of 38 is equivalent to the opposite side, h, divided by the measure of the hypotenuse, 15. And I'm going to write sine of 38 over 1 equals h over 15. And I can immediately go and cross multiply and solve. So when I do, I get h times 1 equals 15 times the sine of 38. So I'm going to go ahead and calculate the sine of 38. And the sine of 38 is 0.6157. And I'm going to multiply that by 15. On the left side of the equation, h times 1 is just h. On the right side, 15 times the sine of 38 is actually 9.23. So there it is. H in this triangle is 9.23, which we would say, actually say that it is approximately 9.2. We're going to round our answers to the nearest tenth. And finally, last example I have here, what is the measurement of side AB in the right triangle? So side AB is here, so I'm going to label it with an X. So I have 35 degrees as my reference angle, and X is opposite of that, but 12 is adjacent to it. I don't have the hypotenuse. The hypotenuse is unlabeled, so I'm not even looking for it. So what ratio am I going to use that relates the opposite side to the adjacent side? I need to use tangent. So I'm going to use the tangent of my reference angle. So the tangent of 35 is going to be equal to my reference angle, or excuse me, the tangent of my reference angle is going to be equal to the opposite side divided by the adjacent side. So here's my trig ratio right here. Tangent of 35 over 1 equals x over 12, and I can cross multiply right away. I'm going to get x times 1 on this side, and I'm going to get 12 times the tangent of 35 on the other side. On the left side, x times 1 is just x, and the tangent of 35 is 0.7002, and multiplied by 12 is 8.402, which we would say is approximately 8.4. So there it is. The measurement of side AB is 8.4. So that's it, guys. In summary, right triangle trig is all based on SOHCAHTOA. You just got to know which ratios you need to use based on the side measurement that you're missing and the side given side's location. You know, basically which two are you given, which two are you being asked about. And then it's just studying it up and cross multiplying and solving like a proportion. So that's it, guys. Thanks for watching, and I'll see you in the next video.